Okay, welcome back. This is Mark Stump, October 2013. I'd like to talk about what stop is. One stop, two stops, three stops, half a stop, two-thirds of a stop, one-third of a stop. Actually, I probably won't talk about fractions of a stop. I'll just leave that to your imagination. But I'm going to talk about this in relation to shutter speed, ISO, and aperture. Aperture will be a tiny bit confusing, well, more complicated. And so let's start off with simple. Shutter speed. My first camera was the Pentax K1000, and the only shutter speeds available to me were, and see if you see a pattern here, 1/1000th of a second, 1/500th of a second, 1/250th of a second, 1/125th of a second, 1/60th of a second, 30th of a second, 15th of a second, 1/8 of a second, 1/4, 1/2, 1 second, and then bulb. But except for a little bit of rounding, each one was a factor of 2, different from the one from those shutter speeds that were next to it. So, for instance, 1/125th of a second lets in twice as much light as 1/250th of a second, and approximately half as much light as a 60th of a second. That's one of those places where there's some rounding. You go from 1/25th to 1/60th. That's pretty close. ISOs are full stops in ISO 100, 200, 400, 800, 1600, 3200, 6400, and probably more. Although I'd stay away from anything above. Honestly, I try to stay with the lower ISOs. I certainly wouldn't go any higher than 6400, but it's up to you. Back to shutter speed for a second. When you change the shutter speed by a factor of 2, it should be clear that you're either letting in half as much light or twice as much light, depending on which direction you go. ISO is a little bit different. ISO is, when you change the ISO, you're really just amplifying, when you raise the ISO from the base ISO, you're just amplifying the signal that your camera gets from your sensor. But still, the idea is that you're making it twice as, you're making it more sensitive by factors of 2. 100, 200, 400, 800. Now, aperture is a little bit different. And before I get into aperture, before I get into that, I want to talk about what those numbers mean to begin with. What they mean, and then the math of it. So, I have a 50mm lens here. This is the 50mm f1.4D lens. And D stands for distance, because when this came out in 86 or whatever, Nikon wanted to brag that this lens communicated the focus distance information to the camera. Anyway, this is a 1.4, and written right here on the on the aperture ring, which is how we change aperture in the old days, it says 1.42, 2.84. Okay, but before I get to that, what does f2? What does f2 even mean? It means the focal length divided by 2. Now, aperture. What is aperture? Aperture is like the iris in your eye. In your eye, aperture is a circle, and in your camera, aperture is a circle. In the animal kingdom, there are apertures that are not circles. Cats have slit apertures. Some animals have slit apertures that run vertically, and some have slit apertures that run horizontally. I believe an octopus has an aperture that's sort of in the shape of a W. But anyway, in your eye and in your camera, it's a circle. And the diameter of that circle, in this case, if I set my lens to f2, then the diameter of my aperture of the hole will be 25mm. And f4 would be half that. And f8 would be half. So f2 is an aperture with a diameter of 25mm on this lens. On this lens, f4 F1.4 is 50 millimeters divided by 1.4, which I think is somewhere around 36 millimeters. An aperture with a diameter of 36 millimeters. F8, what is F8? If 2 is 25, 4 is 12 and a half, 8 is 6 1/4. So F8 is a pretty small hole. And that's why the larger numbers correspond to smaller, physically smaller holes. Because the number is the denominator of a fraction. So let me take a quick break here, write something else on my board, and then I'll be right back.